Okay, so the second speaker is Makiko Yamada, and she's gonna talk about the neuroimaging of color quality and beyond, and I'll give warning around 20 minutes.
Okay, thank you. I'm Makiko Yamada from QST Japan, Chiba in Japan. Today we are having this meeting in Nara. Okay, so today I'm going to give 3 topics of talk. First is I'm introducing our neuroimaging study of color Qualia. And then the second, I'm talking about a little about multimodal Qualia for the next stage of the Qualia study. And then the third, I will talk about a little bit about clarification of Qualia structure associated with changes in brain activity patterns induced by pharmacological manipulation. Okay. So here, this is a transformative research area B. We started with now as a representative, and me and Masafumi, and I'm doing this brain activity measurement here. So now I explained a lot about Qualia, so I'm not going to detail, but Qualia is something like we verbally express, but we cannot really know what other people experience. Even though we have the same verbal expressions, our subjective experience might be different, but we don't know how to compare them. So by having this Yoneda lemma, we can compare these two Qualia. We can have this order relationship with other Qualia and then do the same thing. And we, by comparing the relationships of them, we can compare the Qualia of different persons. And in order to test within inside the MRI, we do this experiment. This is the task, and this study was conducted by Takahiro and Mitsuhiro. The poster is presented today. The task is something like that. So there is a reminder here, the color among 9 colors. Then we give the 2 kind of cues. One is report cue and the other is no report cue. So when the report cue is presented, the target appears. Then participants judge the similarity. I'm sorry. And then the target is again shown as a reminder to compare with the next target. And then the other cue is no report cue. So we present the same color, but participants do nothing. Okay. And we can calculate the similarity of all the combination of colors. So here is showing this similarity matrix. Here red and here red. So when we compare red and red, it's same. But when we compare red and green, it dark color, it indicates dissimilar. And we can make this similarity or dissimilarity into the distance. And then this is a 2-dimensional space scaling. We are now, I'm just showing this 2D scaling, but in future we can do this high dimensional scaling. Okay, so this is behavioral result in average. And then here is the individual data. So this is from subject 1 and 2 and 3. And then from these metrics, we can create MDS like this. And here it's the correlation between the all the subjects. So black indicates they are similar. Their matrix are similar. So here it looks like their rating matrix, similarity ratings are quite similar between individuals. But if we look at them carefully, 23, subject number 23 looks a little bit brighter. In that case, this participant was this one. And then you see the spatial arrangement a little bit different from others, okay? And we do MRI, so I'm now going to show the results obtained from fMRI. We first looked at if the color-related brain regions are activated or not. And here, V4 and V8, we see the activations of V4 and V8, which are known for color perception regions. But we are targeting only this bold signal here. Okay. And then V4 is very famous, and many people know that V4 is related to color, but V8 is also important for color, and especially for subjective experience. So there is a study indicating that the color after effects, after images are related to V8, not in V4. And let's experience it. Please focus on this fixation point while, okay, please keep fixate. And I will erase the color, but you will perceive the color, right? This is the after images color. And the authors did this task inside MRI. And then these gray regions are the time period the colors are presented. And then these are fixation point. And if we alternate colors, we don't have after images color, but we have, if we have constant color presented like I did, we feel colors after erasing those colors. And you see these bold signals here, activations are prolonged. And if we subtract from constant colors to alternate colors, the color V4 color responses disappear. But if we subtract from fixation here to fixation here, we have the signals. So this indicates we are feeling colors, and then there are no objective colors outside, but we are feeling the color in the brain, and then the responsible regions are V8, okay? And we found V4 and V8 are activated, also occipital regions, object perception regions. And here showing that hot colors are obtained from our study. We found these regions, and we also found like emotional experience regions, ACC and insula, here and here, and also parietal regions and other stuff, frontal regions as well. And the green are the result obtained from meta-analysis of 236 studies. And our studies are well corresponding to the previous study, visual regions and frontal regions, and also insula and CC. And then, so it indicates that the other color studies also showing this irrelevant, seems to be irrelevant regions, okay? And later, I'm going to show the representational similarity analysis result, and we are focusing on these regions as interest of as regions of interest. Okay. Before going to RSA analysis result, I will talk about a little bit about, I will talk about the report and the no report difference. So the region, the time point we are analyzing is the same part, just observing color. But when we observe the color, when we observe the color to report, or when we observe the color not to report, the brain activation seems to be quite different. Red regions are more activated in report case compared to no report condition. And blue regions are more activated in no report condition compared to report condition. And as shown in red regions, visual regions, occipital gyrus and lingual gyrus and parietal lobe are more activated for report condition, even though they are looking at the same stimuli. And these are visual attention regions. So maybe looking at the color to report may require more visual and more attention brain responses. And I would like to focus a little bit in this middle frontal gyrus here. This was activated more for report compared to no report. Okay, these regions are associated with the different color category. Okay, the study conducted by Bard, they used these 4 colors. This is categorized as green, and these are blue, but a different degree. And these are similar blue and a little bit from greenish blue to blue. And this is green. And when we perceive and these different colors, medial frontal gyrus activations are only observed when we compare green and blue. Okay, but not when not for like similar same category. So same category, even though the degree is different, MFG was not activated. But if once it's different category, these regions are activated. Okay, so when we ask participants to rate the similarity of color, maybe the brain is reacting to the color categorization. And then because we have these 9 representative colors, and they are quite different, like we can categorize when we compare. We cannot compare purely the color of the perceived color, but we are categorizing at the same time. Okay, here the red, here the blue, something like that. So, but when we look at here, these greens, it's I did this study task, and then it's difficult to name these colors differently, and then these are something like to be packed together. And then if we look at the MDS for individual data, a lot of cases are all packed or close to each other. So if we want to pursue if these regions are category specific, category sensitive region, maybe we can compare, we can see if these regions are activated only. If these regions are not activated when we are comparing only these greens, it will kind of prove that color categorizations are present when we are rating the colors. Okay. And here, no report and versus report. And in case of no report condition, we only perceive, we perceive the same color, but we do nothing. In that case, I don't know why, but emotional regions are activated. Okay, insula and ACC and amygdala. Okay. Yeah, this is the result of what we have for now. So let's go to the representation similarity analysis result. Inside MRI, we scan and we extract activity patterns for each color in different brain regions. So red voxel patterns, orange voxel patterns, and we correlate every combination of patterns, and we create this similarity matrix. And we again showing that like something like a red patterns are quite different from green patterns, something like that. And we can make 2D arrangement using MDS in the same way. So here we can create this similarity matrix and MDS and from subjective report and from brain activation patterns. And now what we want to do is how, where in the brain that corresponds to Qualia structure obtained from subjective report. So in order to know that, we simply correlated. We correlated to these matrix and see which regions are more correlated to compared to other regions. Okay, so here are the results. We are focusing only for these regions, these 6 regions. V4, V8, occipital, fusiform, insular, and ACC. And here report condition, and here no report condition. And what we found is in the insular, it was a significant, one sample t-test, significantly different from 0. So that insular was the most the region that are most correlated with the subjective experience or Qualia structure. Okay, but we have a lot of individual differences. Okay, and we looked at what these individual differences are related to individual traits or something. And we found that this score, this correlation of the brain structure patterns and Qualia obtained from subjective report associated with trait anxiety score. So those people who have more anxious, their brain matches to subjective responses. Okay, in case of no report. And in case of anxiety, anxious people, it's it has been reported that anxious people have a lot of responses in visual regions. Usually when we repeat the same images, our brain responses less. It's called repetition suppression. But in anxious people, it does not likely to occur. Okay. So there might be something different in visual experiences or processing related to anxiety. And also here indicates meta-analysis of anxious patients. And it shows that insular are hyperactivated. Okay. So we don't know yet, but insular might be a candidate for Qualia. We still don't know, but the results are indicating something like that. And then here showing that emotional experiences are corresponding to insular. This is something like Voxel pattern analysis, something like what we did. So, and here showing that the visual processing and auditory processing, when they are awareness in the then participants are aware of the visual and auditory stimuli, insular are activated. And then these regions are often ignored in case of past visual studies. But meta-analysis of color processing using fMRI indicates these insular activations. And our in green here, and also our study as well. So there might be something here, regardless of stimuli, our experience might be expressed in some way in INSLA. Okay, and I would like to show the RSA result of raw report versus no report here. This is still ongoing, so we don't have any conclusions yet. But what we did is we have the disseminated matrix obtained from a report and a no report, and we can see how much correlate to each other. And here indicates there are no really correlated, but the V8 is correlated to each other, but inversely.
Well, what's the X and Y axis here?
X is a dissimilarity report, and a report of dissimilarity matrix obtained from report based on Voxel patterns, and this is this dissimilarity matrix obtained from no report of Voxel patterns.
So the pattern flips.
Yeah, flips. Yeah. Okay, but we don't know. So I don't have any discussion about it. But it's weird, but I feel it's interesting to pursue. Okay, but the Voxel pattern correlation is very small, as our study and as in other studies, like subject semantic rating. In that case, like 0.04, and this one 0.004, and this one 0.01, this one, the one that I showed, they did the Voxel pattern analysis and 0.04. And so Voxel pattern correlations are very, very small. So what we want to do for next is discuss with Masafumi tomorrow, and the day after tomorrow, maybe in case of low dimensional scaling, as I have shown, these Qualia structure, the Qualia structure and brain structures are not really matching. It's hard to say it matches. Okay, so what we want to do is we first want to make in a high dimension scaling for both Qualia structure and brain structures, and see how they are matching. Okay, and then Masafumi can transform brain structure to much better, to much more to the Qualia structure. So this is our next plan. And then the other plan is compare the brain responses between report and no report. Statistics are not very strong, but I think worth digging into, because even the perceiving the colors and then the brain responses are quite different. And then this weird thing is happening from RSA. So I think it's interesting to pursue. I don't have any answers to this to understand yet, though. And also, there are individual differences in color placement in hue test, which is very rich information. We have 100 colors, and we ask participants to arrange the color. And here these indicate individual differences in arrangement. And in similarity rating fMRI task, we only had 9 colors. It's poor, so we can include this data to better understand the Qualia structure and the brain responses and their relationship. I don't have any more time, right? Okay, so I would like to go a little bit about transformative research area A and what we are going to do. Next step, Koizumi-san, Ai-san, and I are going to work together, and then we do like three steps. We have 3 steps. We do must be color Qualia, fMRI, and behavior, and multimodal Qualia. And then in aim 2, Koizumi-san do Qualia manipulation and see how the brain patterns are manipulated. And in aim 3, we manipulate the brain patterns, see how the Qualia changes. And then I'm doing a pharmacological manipulation. And then I would like to discuss the multimodal Qualia. This is facial color Qualia. And when we are angry, our face becomes red because hemoglobin is increases. And when we are in this case happy but sad or like calm, our hemoglobin decreases and it goes to pale. So we can simulate these color of face, and we can create different facial color together with expression. And then this time we can do this every combination, and we ask the similarity rating, and we can do this same this matrix and MDS placement, and we do the MRI, and we can compare and then we see which brain regions are connecting the facial color and emotions. This is one plan, and then the next plan is Jong-Yoon, who recently joined my lab, and with him we are planning to do multimodal Qualia like brightness, darkness, warmth, coldness. For instance, we can measure from visual information how the visual information is bright or dark, and we can create Voxel patterns. And at the same time, we can do the same thing from the sound, like by changing the frequency, we feel bright and dark, and we can create a Voxel patterns and see which brain regions are matches, so that we can know this exact the Qualia of like brightness. Okay, and we can also do the this RSA as we are doing in Qualia research. Okay, so and then I'm showing this here, pain Qualia, and here we can provide real nociceptor stimulation in the foot in MRI, so that the participants feel pain together with physical experience. And we can compare this without physical physical experience, but with pain. So in this case, these two have commonly pain experience, but this one no physical, and this one no physical, this one with physical. And we can extract Voxel patterns and see which brain regions are matching. And see, this is pain empathy. You don't have any stimulation in your body, but you may feel something like ouch kind of thing, right? And so inside MRI, we can stimulate body, foot in this case, and then create pain. And then after that, we ask participant to perceive just someone's foot with the needle. And what happened is when we are stimulating C fiber, there are different fibers, and then C fiber. And then when we are comparing with pain empathy, insulin and ACC matches in the Voxel patterns. Okay, this is what we have now. Okay, so and then last, I would like to show the pharmacological manipulation. targeting dopamine. We can use Mazindo, which is a catecholamine reuptake inhibitor, binds to the dopamine receptor transporter, so that blocks dopamine reuptake, and the dopamine concentration increases in stratum specific. In that state, we can measure the brain activity and compare with placebo state and see how qualia structures and brain patterns are changed, so that we can understand better about the qualia structure and the relation with the brain patterns. Okay, yeah. Okay, so this is all. This is the final slide, and the studies are conducted. Takahiro, Mitsuhiro, and Yasunori is going to present a poster about the quantum cognition. So please visit their posters. Thank you very much.